Good evening, guys. Uh, it's good evening, guys in India. Good morning to guys who mostly I'm told that there are a lot of people from US also. So good morning to guys in US. Can somebody just give me a quick, check? My screen is visible. My audio is clear. Can somebody be a volunteer? Let me know if it's all working fine.
It's clear, Mithun. I can
Thank
see
you.
the screen.
Sure. Thank you. Thank you so much. So guys, we'll wait for maybe another half a minute and then let's start. Just give me another half a minute. Yeah, guys. So good evening again. So it's a Monday evening. So I was just thinking some time back that it's a Monday evening, but then Monday evening looks like it's a Sunday evening, because of the lockdown. And if you see, of late, a Sunday evening has become like a Monday evening, right? So I mean, in a way, the weekdays don't matter of late. That's the, you know, good thing about this lockdown. Maybe we are one of those lucky guys who can, actually enjoy working from home. So so that's I mean, so what I wanted to say was Monday evening, Sunday evening is really of not much matter of late. That those are the times we are working in. So so because I was thinking of it's Monday, so I just thought generally we used to look forward for our weekdays, so that we can have some good time with family, friends, and stuff like that. So so what I look forward on weekdays, before the lockdown used to be a visit by my brother-in-law. So my brother-in-law basically is a chartered accountant. Actually, he's also not sure how he became a chartered accountant, but what's worth it, he is a chartered accountant. So what we do on Saturdays and Sundays is that we sit together and we play Xbox. Both of us, play Xbox. And it might sound pretty geeky that two of us are playing Xbox, but we don't know any other game other than cricket. So both of us sit and typically play cricket. And this week, this Sunday, we together sat close to 9 hours, and we were playing cricket. So that's kind of craziness, but that's what we do because both of us are fat, and we can't move a lot, so we play basically online. So so why I'm telling you this was something happened this weekend. So what happened was I chose to be I generally choose to my team is generally the team of Indian team, the men in blue, and he typically is a fan of Australian team, so he picks up Australian side always. So we have been playing in our home we have been playing Australia against India for a very long time. And this weekend something happened which actually amazed me. So what happened was I got a message which said that so in this game, actually in this Xbox game, you can create your own your own custom player. So basically I can create an avatar of mine who will be in the playing 11. So I'm along with Dhoni and along with all the Indian players, I'm also playing in this Xbox game. So what happened was in this series when I was playing against my brother who was representing Australia, I was scoring well. He actually I'm not a good player. He's a very bad player. So what happens because of that is I typically play pretty well. So I got an output in the Xbox which congratulated me for averaging better than Virat Kohli. So believe it or not, guys, I am a better player than Virat Kohli as per the Xbox. As per the settings in which I play. So I was kind of curious that how is Xbox telling me this? On what basis is Xbox saying that I'm a better player? So it's not. It didn't explicitly say that I'm a better player, but what the Xbox told me was that I have beaten Virat Kohli's average against Australia. So let us get into the numbers. So what was Virat Kohli's average against Australia in Test matches? It is 48. So basically what it means is, on an average, whenever Virat Kohli goes to bat against Australia in a Test match settings, he scores 48 runs. And guys, in Test matches, scoring 48 runs every match, it's an amazing number. So having an average of 48 is a very good number. So it turns out that I'm better than Virat Kohli because my average, slightly was better than him, post the last match. So, the whole reason I'm talking to you about this thing is I just, wanted to make this part of the session slightly interactive. And I just wanted to understand from you guys, if I tell you guys that, Virat Kohli, captain of India, averages 48, and Mithun Radhakrishnan, a nobody, scores, has an average of 49. Now, I just want you to understand how is this comparable? Why is averages comparable? Any thought, what is the best way to compare two batsmen? That the literature say let's look into the averages. So I just wanted to get from you guys why averages. Can anybody, who's so following cricket, probably would be in a better position to answer why is average average a good number to look at, I mean, why is average a good number to look at? Anybody would like to give it a shot? Looks like nobody is a cricket follower, so it's okay. So let me let
And
me
yeah,
yeah,
see,
yeah,
because of this is the consistency I feel, because all the players cannot play the same expected, the same every day. So that's what average. One day maybe the good for, right, the because of the situation and the environment, they make
fabulous.
play better. So another day may not be. So because of
Absolutely.
that, average is
Absolutely.
considered.
Absolutely right. So average is, in from a statistics perspective, if I have to bring in, we call it, average gives you the central tendency of a behavior, right? I mean, you might have very good days, as you rightly said. There might be a very good day. I can't take the very good day as the right performance. I can't take the very bad day as the right performance. So my performance would somewhere be in the center, and an average typically is a representative of center. It's actually, there are a lot of question marks whether average is a good representative or not. Will not go there, but we can say that, average typically gives me a feel of, the central performance level, right? So for example, I can tell you guys that, my average in maths has been, close to 95. That's what I've scored in the past. Whenever I've taken a math exam, on an average, I've always scored 95 plus. So that's been my average, not 95 plus, 95. So what it means is tomorrow, if I am going to take a math exam, there is a good chance that I'll score anywhere, very close to 95, because that's what, my tendency has always been. But having said that, I might score 30 also. Having said that, I might score 100 also. That's also a possibility. But if somebody has to make a prediction, he'll typically take an average as a number, because that's a better number to look at. So it turned out this weekend, as I said, I suddenly became a better player than Virat Kohli, because guys, I've spent, close to 10 hours playing cricket, so I have to be better, right? I mean, I have been practicing, so you guys have to give it to me. So so I figured out that that's the way. So the thought process that I wanted to bring to you guys was basically here. Average itself was a model, right? I mean, model in the sense, I was comparing against Virat's model, which was Virat's average, and I was pitching my average against him, and this comparison was telling me how good or bad I am, right? I mean, so here itself, average became a model. So if somebody is playing, what would be his objective in a game? His objective would be to reach the model, right? That is beat Virat's number, right? So basically, what I'm saying is this average gave us a model, and every time somebody is playing cricket, he's trying to reach. He's getting compared against the model, and you can judge whether he how well or how good or how bad he's doing against the model, right? So now in everyday life we don't see these things as models, but these are also, small models. These are very intuitive to us, because it is, because our brains understand these models so well. Probably we don't give them the due respect. We typically run across models which we don't understand. For example, if I tell you something about a neural network or a random forest, people get excited because they don't really know about these models. But average is also a model, and it is also in certain cases good model, or sometimes better than a model which is a neural net model, or artificial intelligence led models. So the point I'm trying to make is, models are models. Models are good or bad depending upon the scenario, the problem they are solving. If they are solving the problem well, they are a good model. Otherwise, it's not a good model. So as simple as that. So, I just wanted to continue our discussion, in the last session. For those for those guys who attended last session would have, faint memories that we discussed about model. In this session, I'm going to talk about a specific model wherein, we would be using a model to solve a business case. We'll use it, we'll try to do it pretty quick. So the use case over here is that every firm goes through this. You have some certain resources at hand, and you have some projects that needs to be delivered. So it's a call, right? How do you allocate resources, right? So there is always this cost benefit analysis that goes on, and based on that, people come up with these kind of allocations. So we'll have a glimpse into how these allocations, how these are done in companies. And guys, this is actually how things work. It's not a textbook stuff. This is actually, and the case that we would be studying also have been picked up. I've modified the data a bit, but it is very close to a real real scenario. So, so before we get into it, let me just quickly set the tone. This is something which we discussed last week. I'll just take a minute to again, bring back to speed those guys who didn't attend. So, this is basically called as the problem solving or the decision making framework. It typically consists of 7 steps. So the first step is called defining the problem. So, obviously, if you want to solve, you have to define the problem. Then you identify the alternatives that can help you solve the problem. Then you will figure out some criteria which will help you judge these alternatives, right? I mean, I can have an alternative which might be very costly. So I might, while it is an alternative, in my cost criteria, it might not fit in. So, I'll have to eliminate it, right? So I'll figure out some criterias which will help me eliminating these alternatives. So the fourth step will be actually evaluating those alternatives against that criteria and deciding, and going about which alternative looks good. And finally, the fifth step is to choose the best alternative, right? I mean, that's what you want to do, choose the best alternative. And since most of you guys are from the development phase, after this is done, typically, the alternative comes to developers, to implement, right? So the developers go ahead and implement that. And there is parallelly some evaluation that keeps happening to figure out how good or bad the decision was, right? So these are the 7 steps of problem solving. Now, decision making is the first 5 steps, and the last 2 is basically, an additional step for problem solving. So these kind of, so why are we talking about problem solving? Because problem solving is, why most of us have our jobs. Otherwise, frankly, we'll not have jobs, right? If there were no problems. So problems are good, right? Because as long as problems are there, we will solve it and we'll get, we'll get paid for it. So moving forward, what is this basically saying is that we are into a journey, wherein we are in some kind of an actual situation, which is not what we desire, right? We desire something else. So we want to move from actual to the desired state of affairs, and that is basically problem solving. So the actual affair is not good. We want to get into some kind of a better situation. That is the desired state. So we tend to move. That's what life is all about. We are progressive people. We want to progress basically. That's the hallmark of mankind, right? I mean, mankind basically is a progressive animal. We want to keep progressing. Every generation wants to be better than the previous one. So that's what happens in problem solving also. We are in a situation which is not really good. We want to move into a better situation, which is the desired situation, and we act, right? We do stuff which will take us there. So, we also discussed what a model looks like in our last class. I'm just running you guys briefly, filling you up. So this basically, believe it or not, is a model. Okay. So what is this saying? It is saying P is equals to 10x. So what is P? P here stands for profit of a company. X stands for the number of units sold. Very much intuitive, right? If you're somebody who's running a shop, your profit will depend upon the number of units that you're selling, right? I mean, as long as, let's imagine you own a milk shop. So if you are selling today 100 units of milk, you'll have some profit. But tomorrow, if you end up selling 1,000 units of milk, your profits will increase proportionately because now your X has increased, right? So this is a model, right? I mean, this is a model which, which is not a very realistic model, but let's assume, it's something which we can understand very easily. But there are some, something called as constraints in life, right? I mean, not everything is objective. Had there been no constraints, we would have been living the life of, let's imagine, Mukesh Ambani, right? I mean, we have to believe it. We are not Mukesh Ambani because maybe we don't have that kind of business acumen, right? So those are constraints that we have to live with. So in this case, the constraint that we had was, we said that it's a 40-hour week. Okay, so only 40 hours can be worked. In 1 week, only 40 hours of work is permitted, and one X requires 5 hours of construction time, or manufacturing time. So one X takes 5 hours to build, and in a week you can only have 40 hours to work with. So basically, your constraint is 5x is less than equal to 40. I mean, if this 40 was not there, if you had unlimited number of hours to work, you could have made unlimited number of excess, right? But you don't have that luxury. There is a limit to the time available, which is 40 hours. So if you solve for this, you'll figure out that you can only make, the best you can do is 8 units, right? You cannot do better than that. How 8 units? 40 divided by 5, that is what you will get. So you can make a maximum of 8 or anything less than 8. That's what it means. So, why am I talking about this? Forget about the math. If you guys have not understood the math, also why they say it, and all these things are, not really useful. What is useful is, there is a function which is basically your model. In this case, it is P is equals to 10x. But, you cannot, so obviously, as a business owner, you would like to maximize profit. You would like to make as much profit as you want. But you live in a world where you have something called as constraints. So constraints basically limit your possibility of profiting. So, the long story short, we have to live with constraints. So we have to do what we call as optimize, right? What do you mean by the word optimize? You figure out how to come up with the best number which will let you live with your constraints, but the number is the best number. I mean, you cannot, that's the best number you can do given your constraints. That's what you want to do. So that is all about modeling basically. So so let's move on to see what is that. So here today I'm going to take you into a real scenario. So this this is about a company. It's not really a company, it's a partnership called Tailwind Consultants, basically. So they have a resource allocation problem. So we'll understand what is this resource allocation problem, and we'll solve this resource allocation problem for them. And believe it or not, we would be solving this using an Excel. Okay. So my whole idea has been, whether, this big, this data science, basically people think that you have to be good at programming, which is actually true. But, the concepts of data science can be, done in a tool is basically something which will assist you. It's not of, primary importance. So you can do these kind of, modeling in Excel also. Excel is something which is kind of underrated these days, but it's an amazing tool. So we will be doing it in Excel, given the time, we want to keep it a short session, maybe, 1 hour, 20 minutes. So we'll do it in Excel. So moving forward, let us quickly talk about, let us understand this, guys, basically, guys, I could just run you through the model, explain you that model, but basically there's no life to it, right? I mean, if you have life to a problem, you'll relate to the problem much better. So that's the reason I'm painting all these, finer details about the context, because, when you understand the context well, something fires in your brain, right? You understand the problem well, and then you try to solve it, right? So that is the reason I'll be spending some time explaining you the context basically. So the context here is about a limited liability partnership called Tailwind. Now Tailwind is basically a group of consultants. Now these are what they call as product consultants, and they are expert in for the industry called fast moving consumer durables. Guys, anybody would like to take a shot? What is fast moving consumer durables? It's a segment of business. Anybody wants to give it a shot? What exactly is fast moving consumer durables? You can type on your chat box if you don't want to speak up. Okay, so again, I think it's not a very interactive group today. That's fine. So let me move forward. So basically, fast moving consumer durables is basically, goods that we consume, and we consume pretty quick. So So things like things that Hindustan Unilever produces or a Nestle produces or PNG produces. These are things which are sold off the shelf and it goes pretty fast, right? These are consumption goods, right? Be it your Kellogg's, be it your whatever you consume. Basically, those are consumer durable, consumer fast moving consumer durables. So product these this tailwind is all about product consultants. So basically they come up with products that can move fast, and their practice is basically in this particular segment. Okay, so what exactly do they do? You know so basically they uncover consumer wants and help the companies convert them into product designs. So now let us let me just take you a slight off the track. I again had a discussion with a couple of one of my associates. So we were discussing again about lockdown and our lifestyles and lockdown and stuff like that. So we were trying to figure out which is the business that is hit the most. Okay, so there were a lot of answers. Every business is hit. There is no one business which is not hit. Every business is hit. So so the one of the businesses which I think is hit pretty bad is the Gillette shaving cream company, right? I mean, I see none of my associates shaving off late, right? I mean, I myself have not shaved for last 20 days. There are a lot of people, because we are working from home, we don't really feel the need to do that, right? I mean, hygiene apart, generally you don't shave if you are not facing the customer. I'm not doing that, so I'm not shaving. So this so my consumption of shaving products have gone down drastically, right? So I was just thinking, so why I brought PNG was PNG actually has a unique problem. PNG is basically has almost 85% of the shaving market. Okay, so look at their conundrum. Basically, if PNG comes up with a new product, if and whenever they come up with a product, who are they going to compete against? A company which actually has 80% of the market, when it comes up with a new product, it's actually going to compete against itself. So let's imagine it has product A, it brings product B. What happens is product B starts eating the business of product A itself, right? Which is not a very good situation to be in, right? So there is a lot of thinking that has to go before you launch a new product for companies like PNG. So it's not that easy. Okay, so there are a lot of scenarios that goes inside, because you might have a very good product, but if you bring that product, it kills your existing product. It's not a good position to be, right? I mean, your new product should give you incremental business. It should not kill your existing business and bring money back home, right? That's not what you want, right? So these are the things that these product consultants typically try to accommodate. They do a lot of data crunching. They understand consumer wants and behaviors. They understand the product designs and come up with the best solution, basically. So Tailwind is also into something like this. It works with companies like P&G, Godrej, etc. So Tailwind has consultants who are the best in their respective consulting areas. So Tailwind is basically a group of lot of consultants who are basically best in their particular consulting areas. So typically there are four consulting areas for this company. First one is technology, obviously. So they have some of the best guys in the technology space. Domain, in the sense here, domain is basically retailing. So you need to be somebody, you need to understand the consumer psyche, right? So you need to have those experts. Then there is a legal part to everything that you do, and there is a marketing part, right? So even if your product is the best of the best, if the legal is not clear, you're screwed, right? Similarly, even if your product is best of the best, the technology you're having is doesn't help. You can't spend a bomb on technology. So all the four areas have to be vetted properly for a product to go into the market. So the good thing about Tailwind Consultants is they have they have expertise in all these four areas, which basically makes them one of the best uh, uh, people to go about for the consumer durable companies. So, so having said that, Tailwind has been very successful, so much so that they have more projects than they are capable of accepting. So the situation is they have a lot of work. They don't have enough people. They don't have enough time. They have a lot of work, right? I mean, that is it's a good situation to be in. Every company would love to be in this situation where they are successful. They have more work than they can do, right? So that's a good thing, but in a way it's a bad thing, because you have to say no to a lot of work, which is not what you want to do, right? So when you have a lot of work and you cannot do the entire thing, then you have no other option but to say no to some of the work that comes your way. So what work will you say no to, right? I mean, the question is which work would you choose to do, and which work would you say, okay boss, I can't do it. So again, it would depend upon some kind of your objective, right? So in most businesses, the objective is to maximize their profits. So I would say no to projects which don't pay a lot of money, and I would accept projects that would not, that are paying me well, right? I mean, as simple as that. So Tailwind is in a situation where they have a lot of projects coming in, but they have to decide which project to choose. And I'm kind of jumping the gun with you guys, by telling you that obviously I'll pick and choose those projects which pay me better, right? Otherwise, there's no sense doing something, right? So that's typically how capitalism works. So the consultant time or resource is the only limitation that restricts Tailwind from accepting all the available projects, right? I mean, why can't Tailwind accept all the projects that they have? They can't, because they don't have enough consultants to do the project, right? They don't have enough manpower to do the project. That's the reason. So, the next thing is, let's start looking into some numbers. So before I jump into that, I just want to know from any of you guys, not clear about, any doubts about Tailwind till here about the business. Okay, I'll assume it's clear. So, let's look into the numbers now. Okay, so again, I'm just, these are numbers that they have projected. Now, this, as I said, Tailwind works for, PNG. Let's assume they work for PNG. So, PNG has these projects which are there. Okay, so the project one is called, Continuing Promise. Oops. The first project is called Continuing Promise. Second one is something called as Saver. Third one is called Active Edge, Arc Light, Autumn Returns, Blade Jewel, Blue Bat. So all these companies, all these MNCs, basically their product ideas are some kind of projects they on which they work, and some projects come see the light of the day, some don't. It depends upon the success of the project. But at one point of time, multiple such projects are going on. So such projects are basically divided into sub-projects. So continuing Promise has 25 sub-projects, Saber has 30 sub-projects, so on and so forth, right? So there are basically 1, 2, 3, 4, 5, 6, 7 projects, and there are basically these sub-projects. Okay. Now, from a Tailwind perspective, for every sub-project that they finish, they get 45,000 rupees. From for a continuing Promise scenario. So if Tailwind picks up Continuing Promise and it does one project for Continuing Promise, it gets 45,000. Now, they have been offered work for 25 such projects. So the maximum that Tailwind can make from Continuing Promise is that project basically is 11 lakh 25,000. That is the maximum they can make. If they do all the 25 projects, they will make 11 lakh 25,000. What is the 11 lakh 25,000 ka calculation? 45,000 multiplied by 25 is 11 lakh 25,000, right? So that's the maximum they can make. Now, do they want to do the entire 25 projects or not is a question that we'll have to answer. Let us, see. So similarly, if they pick up a project called Saber, there are 30 sub projects to which each sub project gets pays them 63,000 rupees. So the total they can make out of this project is 18 lakh 90,000 rupees, right? So it's 63 multiplied by 30, so on and so forth. So basically, what I'm saying is there are 226 such projects available. Tailwind right now has an offer to do 226 projects, and this is a quarterly numbers. This is numbers for one quarter. So in this quarter, they have worked for 226 projects, and if they do all the 226 projects, they are going to make 92 lakh 87,000 rupees. So that's the number that they are looking at. It's a pretty good number to look at. Okay, so this is the demand side of it, right? This is what we call as the demand side. This is the work that they have. Now let's look into what is called as the supply side. So supply side is basically how much can they fulfill. So let us see that. So as I told you guys, there are basically four resources, or basically four consulting departments. First one is called technology, then you have domain, then you have legal, then you have marketing. So all these departments have people, right? I mean, these are experts, right? So there could be, let's imagine there are 5 technology experts in this company, 8 domain guys, legal guys, marketing. There would be number of people in these particular departments, basically. So how you interpret this data is basically, if you want to do one project of continuing promise, okay, if you want to do any one project, let me just clear this off so that there's no confusion. So, if I'm doing one project of this continuing promise, okay, I need to devote 6 hours of technology guy. I need to devote 12 hours of the domain guy. I need to, there is nothing to do with legal. Legal doesn't have anything to do in continuing promise. And the marketing guys have to spend 5 hours, right? So 1 hour, one project of continuing promise requires 6 hours of technology, 12 hours of domain, 5 hours of marketing, right? So if you have to bill these guys, how will you bill it? You will be billing it basically 6 plus 12 plus 5, right? That is the hour basically that is getting consumed. So basically you have 23 hours of work to deliver one project of continuing promise. Okay. Now, how are these numbers getting projected? This is based on their historic data. Somebody from their planning team has looked into the historic data and they have come up with these kind of projections. Okay, that the project called continuing promise will require 6 hours of technology, 12 hours of domain, so on and so forth. Right. So this is based on past data. That is the source of this information. So if you spend 23 hours, if you spend 23 hours on this project which is continuing promise, on one project of continuing promise, you will make 45,000, right? If I spend 23 hours, I'm going to make 45k, right? So if I do all the 25 projects, I will end up making 11 lakhs 25,000, right? So if I have to do all, in terms of hours commitment, what will I require? I'll require 23 into 25, right? That is the requirement to do all the project of continuing promise, right? So guys, any doubt in this computation? Anybody not clear on this? I don't mind spending some more time if it's not clear. But that's a must. So basically, again, just to repeat, in total they have 25 projects which is available. So when I say 25 projects is available, sub projects. So this is the main group. Continuing promise is the, let us say this is the operation continuing promise has 25 projects. So 25 projects has been offered to Tailwind. Each project, if they finish, they'll get 45,000. So if they finish all the 25 projects, they'll get 11 lakh 25,000 rupees. Now whether they want to do all the 25 units or 25 projects or not is something they'll have to decide, right? Tailwind has to decide why they have to decide, because this project requires 6 hours of technology, 12 hours of domain, and 5 hours of marketing. Now there can be some other scenario, some other project which might be paying them more, and it might so happen that the time required there is less, right? I mean, let's imagine, let's for argument's sake, let us take this example, right? Saber example. So Saber is, or let us take, the Blue Bat example. Okay. So Blue Bat says there are 36 projects available. It pays 48,000. The time required is, 26 hours, right? So for 26 hours, they get 48,000. For here, for 23 hours they get 45,000, right? So so somebody has to do a cost benefit analysis to figure out which one is better, right? I mean, and manually, it's a tough ask to do, right? I mean, that's what we are going to rely on technology to figure out which are the best, best combination of projects to pick up. So, so in case of Saber, if I have to take one project of Saber, I need 9 hours of technology, I need 16 hours of domain, I need 4 hours of legal, I need 8 hours of marketing, right? So in total, if I take all the work hours, I need 12 plus 16 is 28, 28 plus 9, 37 hours, right? I have to work for 37 hours in this project, and I will get 63,000 rupees for that project, right? So the question is, which one is better, working for 37 hours and taking 63,000, or working for 23 hours and getting 45,000, right? So that is the kind of comparison that we are looking at, right? So that is what we have to look at. And finally, the biggest thing is, what we have is in a quarter. Okay, guys, I'm repeating again. In a quarter, maximum of technology time I have is 800. So all my consultants put together in a quarter can give me 800 hours. They cannot give me more than that. The domain guys can give me 900 hours. They cannot give me more than that. The legal guys can give 700 hours, not more than that, and the marketing 375, not more than that. So point is, whatever work I'm taking, I have to live within these constraints, right? I cannot take work indefinitely because I cannot deliver that kind of a work, right? I don't have resources to do. I cannot say, okay, keep giving me work, I'll do it. You have a delivery time, you have TATs and stuff like that, you don't want to ruin your name, right? So you want to take only those projects that you can actually deliver. So if you don't have the capability to deliver, capability could be in terms of knowledge or in terms of time resources, right? You have to say a pass, right? So in this situation, these guys have these constraints, right? That they have 800, 900, 700, and 375. These are the time that is available. So I'm just repeating again, I'm just building up because based on all this information is where our model will work. So I'm just repeating for you guys, explaining the layout again. So the layout looks something like this. Tailwind wants to figure out which project to do, which not to do. And how will they decide? They'll decide how much money they make and how much time how much effort they have to put in. So effort again is not unlimited, right? I cannot put unlimited effort. I have limited time and limited strength, so I can only play with that, right? I cannot do unlimited things. So given that scenario, what I have to do is I have to figure out the work that requires me the least amount of work to be done but pays me the most, right? That's the way it has to be. So but having said that, I want to have this quota also filled up, right? I mean, the last thing I want to do is I have 800 hours of technology available and I use only 100 hours, right? So in that case, I'm not I'm underutilizing my technology, guys. So that's also something which I don't want to do. So let us move forward and see how what how life treats us when we have this kind of a scenario. So, so the solution to this is something called as linear programming. Now, linear programming is not the only solution. It is one of the solutions, but it is one of the most used solutions. A lot of people use linear programming for the simple reason it is very intuitive. Intuitive in the sense you can understand the output. And the second thing, the tools are available very easily. Okay, so that is the reason, linear programming is used. I'm hoping that most of you might have heard about linear programming. In your school and college time, this is an actual implementation of linear programming. So what is linear programming basically? So linear programming basically is a method to achieve the best outcome. You are looking to achieve the best outcome in a mathematical model whose relationship is represented by linear relationship. So this is a very important caveat in this, wherein you feel that the relationship is linear, which might not be true. So what do I mean by linear relationship, right? So I'm going to give you guys a pretty very cheeky example. It's not a very textbook example, but maybe it does the job. So the example goes like this: that let's imagine there is a there is a developer who's supposed to go to his office and work on some very important piece of code. Now, before he starts for his office, he ends up having a argument with his wife. Okay, so he has an argument with his wife, and then he goes to his office, and then he ends up making a mess out of his code. Basically, he's not able to work well. He's not able to concentrate. His mind is always going back to the argument with his wife, right? So, can we attribute that the work loss, that the reason why he is not able to concentrate is because of the argument with his wife? So if we attribute that, then we are giving a linear relationship. That then we are saying that everything that has happened is because of the argument with his wife, right? But it might so happen that the performance reduction is because of multiple things, right? I mean, there could be he missed his train, or he missed his bus, or he didn't get his salary for that month. So there could be a lot of other reasons because of which he's actually not able to concentrate. So if there are a lot of other reasons, so that means it's not a linear relationship, right? I mean, there are variable other factors which are working. So you cannot attribute all the underperformance to the argument to his wife, right? So here what we will be doing in this model is basically we are going to assume a linear relationship. So when I say linear relationship, I'm going to see that the behavior of the variable, that is, the reaction of this variable, which is, in this example, the reaction was the underperformance at office, is basically because of the, the quarrel with his wife, right? So, you're going to attribute everything to that one factor, and that is called as a linear relationship in a very crude way. Okay, in a very crude way. There are other non-linear relationships, which is which is not a part of the discussion right now. But that's where I mean neural network or a random forest. These are algorithms where you are looking at a non-linear relationship. There is the relationship is defined in a different way, which is not pretty linear. So so long story short, this in this modeling we are going to pick up linear programming. And guys, linear programming is again very very powerful and very very useful. It sometimes because AI and exotic models like random forest or neural net is so glamorized, you feel that linear programming is tuch or small prani, but actually it's not. It does a lot of heavy lifting pretty well. So let's spend some time on linear programming. So in the to solve the problem of this tailwind situation, to solve tailwind situation, we would be using a solver add-in in Excel, in Microsoft Excel. So guys, quickly type in on your screen in the chat box who all has heard about solver add-in or has used solver add-in. Just type yes, guys who have used it. Okay, so I'm glad that I see a lot of no's. So that means this, the selection of the choice was, this lecture was good. So let's move forward. Okay, so a solver is an add-in which sits on top of Microsoft Excel, which can, which helps you with doing linear programming. So we would be using solver to do, solve this project basically. So moving forward, the goal is to determine the values of decision variables that will maximize our objective function while adhering to the constraint. So again, it's a mouthful, in terms of the language that is used. Let's break it down. So what I'm saying is my goal basically is to find out the values of decision variables. So, I want to find out decision variables and values for those decision variables that will maximize my objective, right? That will maximize my objective while adhering to the constraints, right? So I have certain constraints, I have some objective. So I want to maximize my objective. So I have to figure out the values that will maximize my objective given my limitations, basically, right? And this is the story of our life, right, guys? I mean, we are most of you are spending time in this, webinar because you want to, move forward, right? You feel that maybe you learn something on the data that would help you out with your career, right? I mean, so that is the, because your current career might be giving some kind of constraints to your growth. Given your situation, you feel that attending these kind of webinars will help you improving, and that's what you're doing. So you're maximizing your objective, adhering to your constraints, and there are some decisions that you have taken. So the decision, this mail would have gone to a lot of people to attend this webinar. Now you are attending, somebody is not. So that is the decision that you have taken to attend because you feel it maximizes your objective. Somebody would have decided not to attend because because they might feel that it doesn't serve the purpose. It doesn't maximize their objective. So everything that we do basically is fits in this line. Our goal is to determine the values of our decision variables that will maximize our objective, ensuring that we stick to our constraints. Constraints cannot go away, right? I mean, we wish it could, but it will not. So what are decision variables basically? In this case, in Tailwind's case, decision variables is which project and how many sub projects to accept, right? I mean, Tailwind, as I said, is in a lovely position where they have to decide key, which project I should take and which sub project I should take. They are choosers. They are not the beggars, right? And why are they choosers? Because they are the best of the best. They have the guys who do, solid work. That is the reason they are choosers and not beggars. But having said that, coming back to our model, the decision variable here is which project to choose, how many sub projects to choose, right? That is what we have to decide. Going back, if I have to show you back, I'll have to say which among these projects I should take. There are 7 projects. Which project should I take? Which, I mean, and these could be multiple projects, obviously. And how many sub projects should I choose, right? How many sub projects should I choose so that I can maximize the revenue, right? So that I can maximize my money. The maximum I can make, if I do everything, I can make 92 lakh rupees, but I cannot do everything. I'll tell you why I cannot do everything, probably going forward. Okay. So, so that's there. So let us just continue with the presentation. The next thing is, what is our objective function? So in this case, the objective function is pretty simple. It is a capitalist economy. People are running for money. So I'm not a charity company. I am here for maximizing my revenue, right? So Tailwind is here to maximize his revenues. That is his objective. So he would pick and choose the projects which give them the best revenue at the least amount of time, right? That's how capitalism works. So constraint is basically I cannot cheat the guy, right? I cannot keep cheating people because then I'll not get the work again next time, right? So if I don't have the resource, I'll have to say, I'm sorry, I can't do that, right? So resource availability is a major constraint, So I'm just setting up the setup again for you guys. And the last thing that we have to assume over here is the assumption of linearity, wherein I'm saying that the project so in this particular scenario, how does linearity come into picture is I'm saying that my model, basically my decision, are going to be completely driven by the numbers that I have, right? But that may not be the case. That sometimes might so happen that the project saver is so good, in terms of knowledge and stuff. Even if it pays me less, I would like to do it, right? So that I'm assuming against that. I'm assuming linearity, right? So that's the assumption that we have in here, and that is the reason we are going to use linear programming. Now, guys, I'm just touching and going on linear programming because linear programming in itself is a sizable topic. So let's use linear programming, and maybe we'll discuss linear programming in one of the later sessions. Okay. So right now we are going to, so let me tell you guys what I'm trying, what I'm telling you guys is basically you are going to treat it as a black box. Now, what do you mean by a black box, right? So black box is something, which is a box. You give an input and it gives an output. Okay, so let me just tell you, so this is a box. Okay, so this is what I call as my black box. And inside the black box there are some operations happening. I don't know what's happening, but something is happening. I give it some input and I get some output, right? That's what is happening inside black box. So I'm going to assume linear programming as a black box. What happens inside the black box, I'm not going to understand it at this point of time. I'll give this black box some inputs and I will get some output. So our aim in this session is to understand this output, is to understand this output and make use of this output. That's what we want to do right now. So, but it's, from a data science career perspective, that's not the way to go forward. Initially you do it this way, but later on you open up this black box, right? If you want to be a really good at data scientist, you really want to unbox this box and look inside it, that how exactly linear programming goes about doing its work. And then so I mean, you really don't have to do that because black box is the tool, right? I mean, in this case it's the solver which will do all the heavy lifting of the math, but you still need to, it's a good practice to know how exactly solver go about doing, about solving that problem. But from a practical perspective, you don't need to know the math because the output will give you the math. So in this webinar, we are going to interpret the math, right? We are going to interpret the output basically. So let's continue forward and see what's happening. Okay, so so before I put my data inside the tool, right, which is my Excel and my solver tool, I'll have to formulate the problem. Okay, so now so let us spend some time formulating the problem. Okay, so something went missing. Okay, yeah. So the objective function that I have defined over here, so this is my objective function, is basically maximize. Now I have no doubts about maximizing because this is about my revenue. Okay, so Z is basically the the coefficient that I'm using for my profits. Okay, so Z is a function of 45,000 x1. Okay, so 45,000 basically is the is the revenue that you get if you finish one project of the first project, right? I mean, if you guys want, I can quickly take you back to that slide. Just give me a minute. Right, you see this 45,000, right? 45,000 is the amount that I get if I finish my first project. 63,000 is I get if I finish my second project, right? Of the project two, right? So this is how it is laid out. So now what I've done is from a mathematical modeling perspective, I'm calling my my revenue as Z. Okay, Z is my coefficient for revenue, and what I'm also doing is I'm giving coefficients for each of the projects. So the first project is called X1, second one is called X2, so on and so forth, right? So I have 7 projects, so they are called X1 to X7, right? So that's how it is laid out. So now what is my objective function? My objective function basically is to maximize 45,000 of X1 40 plus 63,000 of x2 plus 27,000 of x3, so on and so forth, right? So this number, if I have to maximize this number, I have to maximize, if let's imagine x1 is, there is, what is x1? X1 is the coefficient of the first project, right? So if the value assigned to x1 is, let's imagine 10, okay, so what is the value of revenue that I'll generate from the project 1? I'll generate 45,000 into 10, which will be 4,50,000, right? So whatever is the value that I'm assigning to these coefficients, right? x1, x2, x3, I want to assign coefficients such that it maximizes my z value, right? It maximizes my revenue. I'll just repeat this, guys, again, right? It's a basic simple mathematical model, but I think I might have rushed you guys, so let us slow down a bit. So what am I saying over here? I'm saying that z is my revenue. Okay, so that's clear. Now z is a function of 45,000 x1. Okay, so what is 45,000? 45,000 is the money that I make from, if I finish one project, first project, right? Project one, if I finish, I make 45,000. So x1 is what I call as the project one. X2 is what I call as the project 2, X3 is what I call as the project 3, so on and so forth. So my X1 was basically continuing promise, right? I mean, if you guys remember, the name of project 1 was continuing promise, okay? So continuing promise basically told, we have 25 projects, sub-projects of continuing promise, right? That's how it was, right? So the question is, how many of continuing promise should I do so that I can maximize my return? So I don't know these coefficients right now. My job of my algorithm basically is to find out coefficients for this x1, for this x2, for this x3, for this x4, for this x5, x6, and the last x7, such that my z value is really large. I want to choose these x's such that I can maximize my revenue, right? That's what I want to do. But then if that is, if this objective function was living in isolation, living in a in a world where there was no constraint, then there was nothing, right? I could have said, okay, I'll do a 1 lakh projects of x1, I'll do 2 lakh projects of x2, 3 lakh projects of x3, so on and so forth. So I can maximize my revenue like crazy, right? If there were no constraints for these projects, I would have maximized my revenue like crazy. But that's not the case, right? I mean, the case is there are some limitations. So let us understand what all are the limitations first. So this, so when we talk about limitations, we reach the world of constraints, right? So that is what we call about constraints. So what is the first constraint? The first constraint says that I only have 25 projects of 25 sub projects of the operation continuing promise. So what it means is I can do 25 or less than 25, right? I cannot do more than 25. Guys, can I do more than 25 of x1? I cannot do more than 25, right? I mean, that is what I have an offer, right? I mean, let's imagine PNG is giving me this offer. So PNG is saying that I have 25 sub projects for you. I don't have the 26th one. So Tailwind has a choice to do all the 25 or less than 25, but it cannot do more than 25, right? So my constraint is x1 can be less than equal to 25. It cannot be more than equal to 25. It has to be less than equal to 25. X2 has to be less than equal to 30. X3 has to be less than equal to 47, 53, 16, 19, 36. Okay, so let me take you guys back to the data, so that you guys can get a better picture of what I'm saying. So you see that, guys, so what I'm trying to tell you guys is, oops, this, I have 25 projects, right, of continuing promise. I just have 25. I don't have the 26th one. So I have to tell my algo that, guy, stop at 25. Don't look for the 26th project because I don't have the 26th project, right? So I have to tell that to the algo that, there is a limitation for continuing promise. The maximum we can go till is 25. So we can choose in between 1 to 25, but we cannot choose the 26th one, right? That is the constraint that I have. So I have similar constraints for all my project, right? I have Sabre has 30, Active Edge has 47, 53, 16, 19, 36, right? So these are different projects, and these are the maximum that projects I can do, right? So I cannot do anything more than this. So so before that, guys, I just wanted to uh, you know I'll keep this. Yeah, I'll just quickly show you guys that in an Excel sheet. So let me just share it. Yeah. So this is the same data in Excel sheet. Eventually we will come over here. So if guys, if you see over here, if I have to do all the projects, right? If I do all these projects, so there are 226 projects that are available. So if I, so let's imagine I have to do 25. Let's imagine I'm doing the first project called Continuing Promise. I'm doing all the 25 sub projects. So if I have to do all the 25 sub projects, I need 6 hours of technology, 12 hours of domain, and 5 hours of marketing. So totally to do all the 25 projects, I'll require 575 hours. Okay, guys. So just to do the first, first project, first project basically, first operation, let's say the product, basically Continuing Promise product. If I have to do, so guys, let me just clarify. I think there is some confusion might have crept in. Continuing Promise is a product line. Okay, this is a product line which offers 25 sub projects. Okay, so there is one product which with 25 sub projects. Each sub project gives me 45,000. That's how it is laid out. So if I do all the 25 projects, if I do all the 25 projects, I need to spend 575 hours. Similarly for Sabre, if I do all the 30 projects, I'll need to spend 1 lakh, 1110 hours, right? So this is how I have to spend. How I have computed it, it's fairly simple, right? It's Excel. You can multiply 6 into 25, 12 into 25, so on and so forth, and you get the output basically. So if you see, I need to spend totally, if I have to do all the projects, I need to spend 5,432 hours. Okay, that's what I have to spend. And how much time do I have? Actually, I just have a total of 2,725 hours. So that is my problem. My problem in life is the work that I have to spend 5,400 hours doing it, but I only have 2,700 hours to do it, right? So that is my problem basically, and that is the reason we have set into this, we have set into this exercise to figure out the best combination, because I can only spend 2,775 hours, and I have these options of work to do. So if I do all the work, I get 92 lakh rupees, but I know I cannot do all the work. So I'll have to be happy with less than 92 lakh rupees, but I want to maximize that amount, right? I want to find out the combination where I get the maximum, if not 92, I get the maximum of, maximum of that. So that is what basically I want to do. And let me, continue with the presentation. Oopsie. So, so that's what I wanted to do. So my first constraint basically was in terms of the number of projects that I have. So the number of projects that I have is, for the first product, I have 25, maximum of 25, 30, so on and so forth. So this takes care of my number of project constraint. This is, I have to, when I'm doing my coding, or when I'm doing my formulation in Excel, I have to put this constraint. The second thing, that the other constraint that I have to look is this one. So this is resource wise. So this is basically your technology resource. The first one basically attributes to your technology. So it has 6 of x1, 9 of x2, 4 of x3, 4 of x4, 7 of x5, so on and so forth. The maximum, all this put together, cannot be higher than 800, right? So how am I coming to this? What this means is basically this stuff, right? So what I am trying is this, whatever work I do, how much ever I spend time on, maybe Continuing Promise, Saver, whatever project I'm going to do, it cannot be more than 800 hours for technology. Technology cannot, I don't have people who can do more than 800 hours. Maximum I can spend hours is 800. So, any combination that goes cannot be more than 800. It can obviously be less than 800, but not more than 800. In terms of domain consulting, again, my constraint is I have 900, legal 700, 375. That's the way it is laid out. So going back to my presentation, so this is how, the technology constraint is, expressed this way. The technology time constraint, when I say technology constraint, this is the technology time constraint, this is the domain time constraint, this is the the legal time constraint, and the marketing time constraint, right? So these are the constraints that I live in, right, guys? So if you express this in the mathematical terms like this, your job is done basically. Now, I'm not sure how good a job I have done. Maybe it's slightly overwhelming to look into these things as numbers on your screen, but it is very, very simple. It's basically you have a coefficient and you're giving the coefficient against it, and you basically want to maximize that coefficient because your objective is to maximize. As simple as that. So, guys, this is how the formulation has worked up. Any doubts? I can spend time again if you want. Any doubts on anybody who's not happy with the explanation, wants to revisit what's happening? Types. Everybody clear with what's happening over here? How the formulation has worked?
Yeah, Mithun.
Fine. So, so let's keep moving. I'll share this presentation. The last one is still not shared, I guess. I think post this session, they will be sharing it. So, so let's now do that in Excel, right? I mean, let's move into the, activity. All these things was what we did was to understand basically, how things gets laid out. So this is the solution, but let's do it in the Excel basically. Oops. So let me go to the tool. Now the tool of choice over here is Excel. Okay. Now why it's Excel? Because this problem can be solved in Excel for the simple reason that's why we are doing it. But you can do it in R, you can do it in Python. So what I want you guys to understand is that this is a limited data problem, right? I mean, because Tailwind is not a very huge company, right? And all the data crunching is pretty limited, so you can use an Excel. But with if you just really imagine, for let's imagine for PNG in a year's time might be spending, might be running parallelly a lakh or more of such small projects, right? So they cannot put their data in an Excel and try to project. They need some kind of a more sophisticated tool, but at the end of the day they would be doing something similar to what we are going to do in Excel right now. Okay, so let us quickly lay out the let me just quickly explain you the layout first, and then we'll run the solver. So before that, guys who are new to solver, I'll tell you how to execute solver. First you have to go to your data and look whether you have the solver option over here. Okay, so you have a data tab in your ribbon, okay, in your Excel, and if your solver is already installed, you will see something like this over here. Okay, and if you don't see it, what you have to do is go to your file, go to options in this ribbon, go to the options menu, and in that you will have add-in options. Okay, so click onto the add-in options, and you have multiple such add-in options. One of them would be solver. So once you click over here, click OK, it will get executed. In the sense, it will get added to your Excel. Solver will get loaded on top of your Microsoft Excel. So it's earlier it used to be difficult. Now it's available in the since we are in, most of us are in India, even in the pirated version you will get solver. It's not that you really have to get it, but it's a good practice to have a genuine version of Microsoft Excel. So having said that, let me just tell you guys again the way to go into your data, look for solver. You should get it. If you don't get it, go back to your file menu in the ribbon, look for options. Okay, and in the options you should see add-ins tab. If you click onto add-ins tab, you'll get multiple add-ins. One of them should be solver. Somebody is saying, yeah, fine. So yeah, so so this is the so this is the spreadsheet now. So all this all that PPT stuff was for generally I don't have to make those PPTs, because if I'm dealing with myself, I'm happy with my Excel, but I use that PPT so that I can explain. I'm not sure whether I did a good job, but let's continue. So that same information right now is posted in front of you guys in an Excel. Okay, so let me just tell you guys again what's available. So the project type, let me change the project to, let us say, product type. So I'm not happy with that name, nomenclature. So product type, so you have a product type called continuing promise, saber, active edge, arc light, blah blah blah, and number of projects available. So within a product there are number of projects that are going on. So number of projects available for Tailwind is so on and so forth, right? So under the product continuing promise, there are 25 projects that are available. Tailwind has to decide how many projects it want to pick it up, right? So that's the way it has been laid out. So for every project Tailwind does of continuing promise, it gets 45,000. For Saber, for each project 63,000, so on and so forth. So now how this sheet is layout, let me, guys, just stay with me on the layout of the sheet, because, that's another drawback of Excel, that if you screw up the layout of the sheet, your output goes to a toss, so that's what, programming tools are better with, because, you typically get an error, right? In Excel, you may not see an error, it will, even if you have screwed up with the data, it might, still not give you an error. So having said that, this is the value that I want to decide. Okay, so should I pick up one project, two project, three project? That is what I have to decide, right? So this is what I have. That's why I've kept it in gray color, because this is what I want to decide. This is what the system should do, some kind of number crunching for me, and throw me an output stating, boss, do this project. These many projects of continuing promise, these many projects of saver, so on and so forth, which will maximize my revenue, right? That's what I want to do. So this is, now how this column is defined is, it is, if you look into the, this ribbon over here, formula bar, basically, you will see it is multiplication of C2 into D2. So what is C2? C2 is revenue per project. D2 is basically the number of projects, right? The value selected, basically the number of projects that I'm going to do. So if I do one project, I get 45,000. Obviously, if I make it two projects, I make it zero, I get zero. I make it two projects, I get, 90,000, so on and so forth. So if I do the maximum of it, let us put the data, 25 units, 30 units of this, 47, 53, 16, 19, and the last one is 36, right? So if I do all the projects, I'll make 92 lakh 87,000, right? So that's the maximum I can make. So can I do the entire projects? Yeah, I cannot do it because I have a resource limitation. So that's the scenario. So we want to predict this number. This value is what the computer, whatever it does underneath, the algo should come up with an optimized number for this value. And what do I want to optimize? I want to optimize this value, right? This is the revenue number, and I want to maximize this revenue. So this is what I want to do, but I have some limitations. So let's go into the limitation side of the sheet now. So limitation side of the sheet is laid out something like this. There is a resource called technology, which for continuing promise, takes 6 hours, 12 hours of, the domain. Legal takes 0 hours, marketing takes 5 hours, so on and so forth. Let me just change that. Right, maybe that's better. Yeah. Okay, so this is how it looks basically. So this is my problem, right? So totally I'm laying out that I have 800 hours available, but if I do all the projects, right, this is what I was telling you guys, right? If I do all the projects, I need, 1300 hours of technology. Now how have I computed this value? This value is basically, guys, stay with me, A14 is basically, how do you read this table, right? Continuing promise is basically your product, and if I want to do one project of continuing promise, I need 6 hours of A, 12 hours of B, 0 hours of C, and C, in the sense, what I mean is legal resource, and 5 hours of marketing, right? That's what I need, right? So if at all I'm, so what am I doing over here? I'm making this cell reference as A14, that is this cell multiplied by the number of projects that I'm taking, right? In this case, I'm taking 25 projects. So A requirement would become, in first case, 6 multiplied by 25. Second would become, 9 multiplied by 25, 9 multiplied by 30, so on and so forth, right? Why 9 multiplied by 30? Because in the case of Sabre, I need 9 hours of A technology, right? A requires 9 hours, and there are 30 such projects, right? So it would become 9 into 30 is the requirement of technology resource. Guys, there with me, have you understood what I'm trying to tell you with this cell? With this cell, please, just type it out on the Excel. Somebody who's not, who has not understood, I don't mind spending time. This Excel would be sent to you guys positively by, first hour of tomorrow. But it's plain and intuitive. Once you see the Excel, it should be plain and intuitive. I go with Komal's word. She says she's understanding, so I'm continuing. But it's pretty simple. What you're doing is you're basically, defining, you're connecting these cells such that you're multiplying whatever value I'm selecting for the number of projects that I'll do. I'll get a corresponding hours, that I need to do for A, for B, for C, for D, right? That's how I've laid out. So if I do all these projects, that is all that is available. I would end up requiring these many hours. And as you guys can clearly see, I don't have this bandwidth, right? I mean, my company doesn't have this bandwidth. Tailwinds don't simply doesn't have the capability to, provide these kind of numbers. It can maximum do 800 hours of technology. The ask over here is 1300 hours, 900 hours of, what is it? 900 hours of domain. Practically I need double the time, right? So I clearly don't have the bandwidth. So I have to figure out, cut and, lose some of the projects. That's what is happening over here. So this is how the sheet has been laid out. And guys, like it or not, the problem with Excel is if your layout of sheet is not correct, your output will go for a toss. Okay. So let us now get to the output side. Okay. So now output is a beauty. It's just a click of a button. So let me go to data. Let me call up the solver. Okay. So when I call up solver, I'll get prop up something like this, right? I mean, this is a layout which comes in wherein I have to give the details. Okay. Now because we are in a session kind of a situation, I've given all the constraints already, so that, it's easy for me to run. But let me just explain you what is this doing. So the first, the first the first field that I have to fill up is called set objective, right? So I have to set objective. So in this case, my objective is basically this cell, right? So the cell references $E $10. So when you put dollars basically in Excel, what happens is that particular cell gets frozen. Okay, it doesn't move basically. So I have set my objective function to this cell. Now, why this cell? Now this cell is my revenue, right? And what is my objective? I want to maximize my revenue, right? So what is my life goal? What is Tailwind's life goal for this quarter? They want to ensure that this number is the biggest number, as big as it's possible. Obviously they cannot get a 92,87,000 ka number, but whatever is the next best highest number, they want it, right? That's what they want to do in life. So I set my objective to that cell, as simple as that. Then I also have to set my objective. So you have basically two choices, three choices, in fact. Maximize, minimize, or value equal to something. Okay, so we are not going to spend time on minimize and value over here, because the way our problem is set up, our problem is a maximization problem. It's not a minimization problem. I don't want to minimize my revenue. I want to maximize my revenue, right? So that is the reason I would choose max over here. But let's imagine you're looking at a cost function. Let's imagine there was a scenario which was different, wherein the company, off late everybody's doing it, guys. Actually, it's happening, because of the corona crisis. Everybody is trying to reduce their costings, right? I mean, so everybody is going back to their cost sheets, trying to figure out, what is the way to minimize their cost, right? So if that is the case, your objective will become minimized. You can also set a value. Let's imagine I want to keep my value at X number. I can put that number. So right now, let's stay away from these two options. Let's stick with the problem in hand, maximize. So my objective is to maximize. The cell that I want to maximize is this cell which I have chosen. How do I choose over here is, you click onto this, you go to the cell, you click it again, and that's how it gets chosen. Okay, so that's there. So that's the first argument that you give. Then the next thing it's asking is, okay, maximize. The Excel is, let's imagine Excel is talking back to you. So it is saying, okay, I understood you want to maximize this cell, but what do I change to maximize this cell? You have to tell the tool that which are those arguments that has to be changed. You changing which arguments can I maximize it, right? You have to tell that. So what are those? That is a cell range D2 to D8. Yeah. So the cell range is D2 to D8, which is basically this cell, right? I mean these values. Okay. Yeah. So somebody needs to go on mute. I'm sorry. Yeah, it's fine now. Thank you. So why are we selecting this? Because these are the values that needs to change, right? I mean the number of projects that get selected, right? I mean, do I do 25 or 10 or 3 or 4 or whatever is the, if the Excel will go and check each of the attributes, figure out a way which, will ensure that by changing this, what will maximize, right? So that's what I do. And then finally, I'll put all my constraints. Okay, so I have to put all my constraints. So these are, the first constraint you see is it reads A23 is less than equal to 822. So let us see what is 823. So 823 is this cell, right? 823 is basically your your R's usage, right? So your R usage have to be less than or equal to 822. 822 is the maximum bandwidth that I have, right? For technology, I can do 800 units, right? So this has to be less than or equal to this, right? So that's how the solver has to solve. So first condition is for technology, it has to be less than equal to 823 has to be less than equal to 822. Next option is B23, which is pertaining to domain. So B23, which is this cell, if you guys, I'm not sure whether it's conveniently visible or not, but if you see this cell has to be less than equal to this number, B22, right? So on and so forth. C23 has to be less than C22. So what is C23? C23 is basically the legal hours. So legal hours maximum I can do is 700. So I have to give a condition that maximum, I can do is 700. So what is basically happening when you are giving these conditions is you're basically giving a constraint, right? So when I say 823 has to be less than equal to 822, what I'm saying is that this cell, the resident of this cell has to be less than equal to this number, right? I mean, that is the constraint that I'm giving. That is the condition that I'm giving to the computer, basically. So I have four constraints for this, right? I have four constraints for the resource availability constraints because I have four resources, and then I have a series of seven constraints. So what is seven constraint? Basically, I'm saying, let us see, D2 is less than equal to B2. Okay, so let us see what is D2. So D2 is this, this should be less than equal to B2. Okay, so what does that mean? What it means is I can choose 25 projects or less than 25 projects, but I cannot take 26 project, right? Because I don't have the 26 project, right? So I have to tell computer ki boss, you have to restrict yourself to 25 projects, because that is the condition. I don't have the 26 project. So I have seven such conditions wherein I'll say that D2 is less than equal to B2. I will say that D3 is less than equal to B3, right? Because 30, whatever resides over here cannot be higher than this number, because that is the maximum project I have. Similarly, D4 is less than equal to D5, B4, and so on and so forth. So these are the 11 constraints that I have. The seven constraints, are related to the number of projects that are available. This is the maximum that is available. So I have to tell the computer that this is maximum that is available. Choose something less than this, either this or less than this, but you cannot choose more than that, right? So I have to explain that to the computer. The second set of constraints, four set of constraints, are regarding the time available. So I have to say that there are so much of a technology time available, so much of domain available. So you have to restrict. I have to tell the computer to restrict itself within these limitations. Okay, so that's how I code it. So how do I put constraints? Again, it's pretty simple. I click on to add over here, then I put the cell reference range. So let's imagine, I say, I want to give it like this. So this cell A23 should be, I can choose greater than, less than, these are the equality statement. Here it has to be less than equal to, and then I choose the target constraint. So target constraint over here is this. So that's done, right? So that's how I put, right? So I'm canceling it over here because this condition is already there. So, I have all my constraints in place. I have my changing cells in place. The entire layout is ready for me to run now, right now. So before we stop, before we actually run it, you have to tick this option which is called make unconstrained variables non-negative. So what you are saying is that you don't want negative variables, and in this setting it makes sense. You cannot have negative projects, you cannot have negative hours, right? I mean, you don't want negative results. So that is the reason, because there is no negative hours. I cannot have -1 hour, -10 hour, or something like that. Similarly, I cannot have minus 25 projects or -30 projects or something. It has to be a positive number. So when you click this, what you're doing is you are ensuring that negative numbers cannot be a result, right? You're saying it has to be out, non-negative. The second thing that you want to choose over here is the solving method. So typically you have these three methods, okay, and simplex LP is one of the most, simplex linear programming is one of the most used methods. Now this is what I told you guys about, right, that this is a black box, okay. You can choose to open it, you can leave it also, if you just forget it and let's move forward, we'll discuss about the black box in some time, but let me first solve the problem, okay. So I've solved it, so I get a something like this. It's asking me, giving me some more options, some giving me some reports related options. I'll keep that for a different session. Let me see, I'm saying, keep this solver solution is what I say. I click OK. So what did just happen? Yeah, so if you see now, this is the output that I have got. Just 1 second guys, something got screwed up in the solver. Let me just see what went wrong. 823. So guys, while explaining to you, I think I've made some changes in the layout. While it is giving me an output, I know this is not the output. Okay, so let us understand what is the output it's giving, and then we'll, so assuming I know this is not the right output. Okay, first of all, I know it's not the right output. Okay, I think I know I went wrong. Okay. Oops. No. 1 second, guys. I think I've repeated some. Oh, my objective got changed, guys. That is the reason. You see, my objective should have been this one, but it got changed. So that's what happens with Excel basically. Now I am hoping everything is fine. Yeah, and so yeah, this is the right solution. Okay, so I figured this out because I knew the right solution, but while I was setting it up, I changed my objective cell basically, and that's why I got messed up. So now if we have to interpret the output, it says that maximum revenue, given the settings, maximum revenue that you can make is 54 lakh 80,000 rupees. This you can do if you do 5.32 project of continuing promise, you do 19.75 project of saber, Active Edge, check it out. Don't do anything of Active Edge. Arc Light, do 2.62. Autumn Return, do 16. Blade Jewel, do 19. Blue Bat, do 36. Right now, obviously, we know that we cannot do a partial project, right? So 5.32 is not possible. So I'll do maybe 5 projects. 19.75, maybe I'll do 20 projects. I'll have to round it up, but that is again another limitation of solver, that it would always give you decimal returns. You have a way to bypass it, but that's again not a topic to be discussed right now, but it gives you a result, right? So what it is telling you is these are the projects that you should take. So if you're taking these projects, you'll end up doing 98 projects and you'll make a revenue of 54 lakhs. Let's look into the time constraint. So what happens is, for the technology guys, you would be using 738 hours. So that means there is overcapacity there, right? I mean, there are 60 odd hours of technology that is unused, but your domain is completely exhausted. Domain guys don't have even a minute's time to spend for anything else. Legal is completely used up. Marketing is completely used up, right? So you are basically using all these three resources fully. Technology is partially used, but you cannot do anything, at this setting, right? So basically, your conundrum basically got solved, that which project to pick up, which not to pick up. So it tells you that Active Edge is a very bad idea to do. You have 47 projects, but you're going to say sorry to everything of them, for the simple reason revenue per project is also on the lower side, right? So common sense also tells you that you should have checked it out. So basically the point, over here is basically to come up with a solution that tells you, the optimum, project to be taken. So when I say optimum basically is ensuring that the best I can make, given the situation. So the best I can make is 54 lakh rupees, which is not bad given, where I was, right? So this is what is happening, guys, whether you like it or not, basically most of the hospitals in India, use this for their staff scheduling, the shift scheduling, because hospitals work 24/7, so shift scheduling becomes very crucial, right? They cannot really leave it to chance. They have to schedule it, convey the schedule to each and every medical worker, so that there is no confusion, right? Because in medical, it's a the response times matters big time, right? You cannot basically screw that up. So it's used a lot. I know many HR guys who use this for resource planning, how to rotate your resources, right? So this is something which is used a lot. But the thought I want you guys to what I wanted to leave in your mind was, this is a way to use data, right? You have basically used data. You have used a tool called solver, come up with an optimum solution. Let's have a look at the solution basically. So let me just take you guys to that. Yeah, go to that last slide of the day and I can leave you guys. So the last slide basically looks something like this. Okay, so it looks like this. It says that do 5.32 project, saver should be 19, so on and so forth. And I'm using everybody to my, this is my, these are the resources, how the resources are getting used. Okay, so the point I'm trying to tell you guys is, as a data guy or as a data analyst, you have done your job. Okay, I'm telling you guys, if you know how to use solver, and if you understand, if you have laid out the problem, you've spent a lot of time on the formulation side, which is very very important. If you have laid it well, you have got the solution and you are going to get paid for the solution. Nobody asks why you didn't do it in R, or why you didn't do it in Python, or why didn't you use Azure, or it doesn't matter. As long as the solution is available, people pay you for that. The point I'm trying to make is, the question is, while doing this, you used something called as a solver, and solver basically was sitting on something, with a word that I used was a black box. So basically solver was based on something called as a simplex method. Oopsie. So simplex method basically is, you have a choice today to ignore simplex method and move forward. So that is what you have to decide, whether you should do that or not. You can always do that. It's not that you should know, but if you want to be a data science or a data analyst of the truest sense, you have to open that black box, figuratively speaking, and understand how simplex goes about doing stuff. Now, question is, simplex will go about doing stuff in some mathematical way. Now, are you supposed to do those mathematical steps ever in your life? The answer is never, 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 ever in your life will you do those steps. Never you'll do those steps. In fact, today, if you are doing an averaging, also you never do the actual arithmetic of average, right? I mean, everything a tool does for you. But you have to understand what the tool is doing, right? What is the simplex method doing? Basically, you have to open the box and understand the math. So when you understand the math, two things happen. One, you feel very good about yourself. You'll feel that, wow, you're a smart chap. Second thing that happens to you is, when this solver should be used, simplex method should be used, and when it should not be used, right? So it's not that simplex can be used in any situation, right? So I've conveniently put an assumption in between and I've moved forward, which I said was the linearity assumption, right? So simplex works only with linearity. So if you're somebody who doesn't understand that, and you keep using linear functions where linear functions should not be used, it's going to be it's not going to be a good model. The model is not going to give you a good result, and because of that you might not get paid well, for the effort that you're doing. So the whole idea of this webinar was to put some thoughts or some ideas in your mind. And that idea basically is that this is the right approach. Once you first learn it on a tool, which is what we are doing, but the tool after that should take secondary instance, and you have to basically open that black box and understand what exactly happened inside it, right? So that is the reason, that is when you become a complete data analyst or a complete data scientist, and your future basically is pretty much good, because you know what you are doing basically. So so again, a side comment is basically, why I'm doing all these things is, basically I see most of the courses that are available in the market. Basically what they end up doing is, they'll tell you the way I've just told you. they'll just run you everything, do this, do this, do this, do this, do this, and this is the output. This is how you interpret the output. But that is the part of the story. It should not end over there. That is the, what do you say, the low value stuff from a training perspective. The high value stuff is, after you have done this, you should actually know how to unbox that algorithm, understand the math behind it or the thought process behind it, so that you would be expert in knowing when to use which algo, right? I mean, this is like a power of god that you have in your hand, but you need to know what to use when, right? I mean, if you're basically you end up having extreme heat when it should be raining. People will not be happy with you, right? If you're god and you're putting extreme hot weather when it should be raining, your disciples will not really be happy with that situation. So similar is your case. So as you go forward, you guys have shown interest in data. So as you go forward in your learning journey, it's not only important to know how to use the tool, it is important to understand what the algorithm is doing, what is the math behind it. For the simple reason, once you know what it is doing, you would be an expert to figure out in which situation it has to be used, right? Because right now, again, I do some consulting work for some universities, for MS students. And I see people use taking up a problem and they run all the algorithms. I've seen a project where a guy has actually spent nothing less than 250 hours on a project. And when I say 250 hours, he would have really slogged his backside off sitting for those 250 hours. He has done all the algorithms for that problem. Now I asked him which is the best algorithm. He doesn't have an answer to that. Which one is suitable, which is, I mean, so he understands, he can run each and every algorithm, but he doesn't know which algorithm is suited for which situation. And that is what will pay you guys. The money is basically in knowing where to use what. So that would come with practice, but that's an objective that you should keep in mind. So with that, I'm in the fag end of this presentation. So again, a quick slide on why do we need quantitative model, because the problem is complex and the management cannot develop a good solution without the aid of quantitative analysis. Now what we did just now, I mean, this solution that we have developed, if I have to develop this manually, it's going to be a pain in my backside. I really don't want to do that, but it's doable. Having said that, it's doable, but I don't really want to do it. So the problem is complex. I don't want to do it. I want a quantitative solution. Second is, the problem is especially important as great deal of money is involved. Again, if a lot of money is involved, I want some kind of a decision making tool to help me with it. Third thing is, problem is new. Manager has no previous experience with which to draw conclusions, so he will take the help of a model. And the last thing is, the model is repetitive, right? I mean, a scheduling, as I said, a hospital scheduling is an every week process for those guys. They have to rely on some systems. The last thing they want is to keep doing it again and again, again and again, every, manually, again and again every week, right? So they want some kind of a system. So and guys, because I have spent a lot of time on the finance domain, it's used like crazy in model. Every in finance you have something called as portfolio optimization. You build portfolios and you want to have a mix of assets such that your risk is limited but your return is maximized, right? So that's something where it gets used heavily. For what is worth, our finance minister, the entire finance ministry uses these kind of linear models, to come up with their budgeting activity, right? Budgeting activity relies a lot on linear programming. So, it's something which is being used heavily, which is something which is underrated but amazingly useful. So I thought, of sharing that with you guys. So with that, the session is over. It's open for questions if you guys have any. Otherwise, we can call it a day. Any questions, guys? Anybody? Any doubts?
So, Mithun, suppose I am a developer. So, how this data analysis job is helpful for developer? I am basically C# coding that I am doing.
Yeah.
So, how
So,
it is helpful for me? I
so
don't have finance background.
yeah. So I mean, Indrajit, if if you understand this, let's imagine you spend time on this formulation side, right? I mean, this is the model that got formulated. So let's imagine you are a part of this formulation. So then you know exactly what to code very simply, right? Otherwise, what I've seen is what happens is something gets communicated to the development side. They understand something, they do something, so it's a lot of to and fro that happens, right? So what will happen, for a lot of, I've seen a lot of success, if I have to term somebody as successful on the development side, I'll say he's somebody who does the development with the least amount of time required. Okay, so that's my definition of a successful developer. So how can he do it in the least amount of time? If he understands what is to be done, in the best way, right? I mean, there is no ambiguity between the requirement that got floated by the person who's actually asking you to do it, and I mean, basically both of you are in the same page, in the sense in terms of understanding. So then you can develop it pretty easily, right? So now what happens with most of the data projects, in the market, and the time overrun that happens is because this communication breakdown happens because the development side will not understand the requirement fully, right? They understand it partially, so then there is a lot of to and fro. And I'm not saying that to and fro can be eliminated completely, it will never, but it will reduce a lot of your problem. Okay, your problem. Now, eventually, what will happen is that you'll become so good at developing the formulation that you'll start meeting the client itself. Okay, because the company will start seeing your value in terms of cutting short the development time. So you'll start meeting the requirement gathering itself will be done by you, so you'll start typically jumping a lot of your growth will not be development, you'll start jumping verticals basically. So you'll become somebody who's jack of multiple departments, and that has a lot of utility, right? I mean, you'll become a guy who's go to for the data projects, and that has a amazingly good value, right? I've seen developers who have become pre-sales experts, so the because they understand implementation is the piece of cake for them. Now they are understanding the model, now they eventually they understand the business requirements. So this is all something which is it's it takes time, it's not going to happen immediately, but that's how it works. So if you I don't have its direct answer for your question, but it's going to be an exponential growth. Once you start doing these things, you would be there everywhere. You would be there on the pre-sale side, you will be there speaking to the client as the face. You'll be talking to the development side. Eventually your development aspect will become more of a supervisory, because then you can probably delegate it to somebody else who can do the development for you, and you can see and understand whether the work that is happening is as per requirement or not. So that is the reason a lot of developers are moving towards this side, because they feel that's how the growth trajectory works. And to my limited experience, I've seen that that's the way it works. Guys who have moved from development side to to basically a slightly on the business and domain side, actually do much better in their careers, in terms of everything. So I don't know, have I answered my question? I don't know, but that it's not a linear. To tell you pretty simply, it's not a linear that you do this course and you'll become a senior developer, or so you'll become something else. It's going to be the benefit you'll see maybe 2 years, 3 years down the line. You'll see the benefit of your hard work right now.
Yeah, thanks, Madhu. It's
Sure.
really helpful.
Okay. Okay, guys. Any other question? Okay, so somebody is asking me to share the PPT and the Excel workbook. I'll do that. It's been pending for a while, so we'll do that. Anything else, guys? Okay, let me just I'm any specific topic that you guys wanted to get covered that would help you. Any ideas on topic that you want me to do? Not that I can guarantee it will be done, but it might be useful to understand the requirement that you guys have. Anything specific, or is it fine? Its value is there with what you're getting right now. Okay, guys. So I think it's amazingly silent, uh, guys, today. So it's fine. So guys, we are basically done for the day. I'll give you another half a minute if somebody has any question. Otherwise, we can just log off. Okay, looks good. Nobody has any questions. So thank you, guys. Thank you for listening. Hopefully, I didn't waste a lot of your time. Let's catch up whenever we have the next webinar. Thanks for your time, guys.